Hello.
Hi.
Today we're going to present our machine learning project about breast cancer, detection of tumors that are cancerous or non-cancerous. So here is our data set. M will stand for cancerous, B will stand for non-cancerous in the diagnosis. And here are some features. We will be having the X for the features. We will drop the diagnosis, obviously, and the ID because it's irrelevant. And then Y, which is the target, which is diagnosis. We'll split data 20% for testing, 80% for training. And we will use logistic regression. After some tinkering around, we figured out the penalty L1 and C50, sorry, give the best results. Okay, then we will fit for training the model and predict, and we'll do confusion matrix, which shows the actual value versus the predicted value.
Okay, and then we calculated the accuracy, precision, and recall scores for our model, which you can see are very high. So that says that our model is really good. Using two methods, the direct method and using formulas that can be calculated using the cross tab, which tell us the true positives, true negatives, false negatives, and false positives.
Yes, this was for traditional machine learning. Then we also did some neural network. We shuffled the data. We changed the B for 1 and the M for, sorry, the B for 0 and M for 1. We also did some descriptive statistics to see some interesting results, some data visualization, seeing, for example, how many diagnosis positive and how many negative, some box plots to see the median, the outliers, etc.
Okay, and then here we just visualizing some features for 5 samples and the output also for 5 samples. Then we did a standardization of the data of the features, as we can see here. And then we split the dataset into 2 parts. So first we have 85% for training, from which we took 15% for validation and 15% for testing from the whole set. And then we can see that we built our model that is formed of those layers. So the first one is the input layer, where we have all the features selected and X before. And we have the output, which gives us the probability, one output. Then we have 2 hidden layers, one with 16 neurons and one with 8. And the dropout layer that helps us avoid overfitting. And then here we can see that we created a dataset, a TensorFlow dataset, which is composed of 16 batches that we shuffled. And we decided that we're going to have 10 epochs or iterations. And we can see here that we're training our model. And we can see that with the epochs, the loss function is decreasing, which is good. And the accuracy, precision, and recall are increasing, which is really good. We have great results. And then we're using the validation data to see how our model responds to new data. And we can see here that with the epochs, the validation data is really good, which showed us that our model performs well with new data. And we don't really have overfitting.
Yes, thank you. We also did some visualization for what you just said about the accuracy and the loss, how they're changing with the epochs and whatnot. And also, we changed the probabilities that we are getting to turn them into 0 and 1, which is the binary predictions. We did that by having a threshold of 0.5, so whichever is above that will be 1. We did some confusion matrix as well and the cross tab, and we can see here the results, which are very good for accuracy, precision, and recall. Thank you. Please subscribe to the channel.